Yeah, okay. All right, so a quadratic equation is something that can be written in this form. Ax squared plus bx plus c equals 0, where the a is not equal to 0. Does it make sense that if a does equal 0, then you have a linear equation?
Yes.
Just like we were solving before? Okay. And so to solve quadratics, you can't use the whole like get x by itself method to just kind of like move stuff around. Like you try to say like move that c over, and you've got ax squared plus bx equals negative c, and you have two things that have c's. Would it work to factor an x out and divide? Why is that not going to work? You still have another x, right? So, poop. All right. So the way you solve quadratics is there are three methods: factoring, completing the square, and the quadratic formula, which comes from completing the square. Factoring is the easiest if it works. The quadratic formula always works, so we'll get to that, and we're actually going to prove why it works to you this time. So the simplest and fastest way to solve is factoring if stuff factors. And that relies on something called the zero product property. And this tells you that if two numbers multiply to make 0, that occurs if and only if the first thing was 0 or the second thing was 0. And 0 is kind of special. Are other numbers like that? Like if a number A times a number B equals 4, does that mean your first number was 4 or your second number was 4? It doesn't, does it? Because they could have both been 2. Does that make sense? Or 1 and 4, right? So 0 is special because it has this property that anything times 0 is always 0. So we're going to use that. So this one's already sort of set up to go. So the way you solve this is you say, well, either my 2x plus 3 could have been 0, or the x minus 7 could have been 0. And generally speaking, almost always, kind of like those absolute value equations, you're almost always going to get two answers in these cases. And those equations, once you've reduced them down to that, they're two linear equations, right? So the first one is 2x equals negative 3. And what's your answer from that one?
-2/3.
3 halves. Yep, 3 halves. You divide 3 by 2. And the other one is x equals 7. Great. Who just walked in?
Someone walked out.
I just walked out. Okay. Someone walked out. Oh, yeah, that's right. Okay, great. Now, before you apply this property, before you factor, you have to make your equation equal to 0. So in part B, how would you do that? Yeah?
So is the final equation or and?
The final equation is or. And I think that the way that the book listed these was they said something like curly bracey things, -3, 2, 7. So the final thing is or. Yep, good question. Or sometimes what I had my students do is they would write x equals -3/2, 7, just saying that x is both of those things. And they'll both work. When you plug them in, if you plug -3/2 in, this first thing is 0 times whatever number that is, which makes 0, right? When you plug 7 in, the first expression is, it's like 15, no, it's wrong, 17 times 0 makes 0, so they both check out. In part B, you want to make the equation equal to 0 and then factor it so it looks like part A. Add 2, yep. So that'll be x squared minus 6x. And it factors into x minus 5, x minus 1. And then you're solving x minus 5 equal to 0, or x minus 1 equals 0. Sorry, I wrote. So what's your first answer? 5? Or x equals 1. So they both work. And if you want to check them, like plug them back in the original, so what's 5 squared? And then minus would be -5, plus 3 would make -2. It's okay. And then with 1, you'd get 1 minus 6 is -4? No, -5. What's wrong with me this morning? My plus 3 is also -2, so they check out. All right, one of the harder ones. So 3x squared plus 7x equals 20. So what's your first thing you should do?
Subtract 20.
Subtract 20. So I did it the long way on my notes where we multiplied and did that grouping thing. So if you're going to use that grouping method, you just got to remember what it is. So how do you start it? Multiply.
3 times -20.
So we need things that multiply to -60, right? And add to 7. Okay. Okay, so it's obviously not 10 and -6, right?
12 and -5.
That's right, 12 and -5. Awesome. Okay, so we'll break this into 3x squared plus 12x minus 5x minus 20 equals 0. Do you remember learning that way with me? Yeah, did you learn it before me too? Maybe? Okay. So what's the greatest common factor in your first set of terms?
3.
3x, great. X plus 4. Second set of terms, very good. And you know you have victory when those x plus 4s match. So now you take out the x plus 4 and you got 3x minus 5. Hello. Goes x plus 4. And once you get to that step, it's just like the first one, right? One answer is 3x minus 5 equals 0, which tells you x equals, I shouldn't go so fast, I'm so sorry, habit. So 3x equals 5, and x is equal to 5/3. And the other one is x plus 4 equals 0, so x equals
4 or
-4. Great. If you can guess and check and get what that polynomial factors into without having to do it the long way, that's also okay. It's probably also good to know it. All right, how about part B?
minus 5x.
Minus 5x, great. Okay, and now do you have to use that grouping thing on this one, or is there something else you can do?
Well, there's no third
Yeah, there's no,
variable, so you mean there has to be no number for the seconds.
yeah.
So you can only take out x.
0 can work, does that make sense? That just thinking like, okay, what numbers work when I plug them in? 0 works, doesn't it? And so what you can tell at this step is, with factoring, you always have that easy pattern we did in the first example. You have this whole grouping thing, and you also have the greatest common factor. Like just, so this one has a greatest common factor, doesn't it? It's x. And whenever you have a greatest common factor that involves x, you're going to have 0 as one of the answers. It's like x equals 0 is just one of the things that works. And the other one is found by setting 4x minus 5 equal to 0. So in that case, 4x equals,
5/3.
4x equals 5, and x would equal 5/4. So things to think, like, is it an easy factor pattern? Is it a greatest common factor? Or is it like the long grouping thing that I have to do? And the hint for greatest common factor is there's no constant term. Okay, so just a couple warnings. One side of an equation has to be 0 before you can do the 0 product property. So for example, sometimes students like try to take this expression and say, oh, it factors into x minus 1 times x minus 5 equals -4, and so Yeah, what should they have done first instead?
Subtract 4. I mean, add 4.
Added the 4 to that side, exactly, plus 4. And the other thing is that this equation and that equation, those equations are not the same thing. So we just solved the first equation in the last example, didn't we? What answers did we get? X equals, 5/4, right? If you just solved 4x equals 5, what answer do you get? Just 5/4. And I bad English, I should have said answer to a second equation is 5/4. How do you think a student would make the jump going from the first circled thing to the second circled thing? What did they do?
Divide by x.
Does that make sense? They divided by x. And so the warning there is you don't divide by x. Because x might be 0. Like x is a variable, you don't know its value, so since it might be 0, you shouldn't divide by it. Otherwise, you're breaking the first commandment of mathematics inadvertently, so it's not quite as egregious as doing it on purpose, but still broken. Okay, so that's just be careful. I think the dividing by x thing probably is a bit more common. All right, now the next ones, you can also solve things so that we have an example where you are missing a constant term, right? What if you're missing that middle term, the linear term? What can you do then? And it turns out you can use something called the square root property. So what this says is if you have some number squared, so a squared equals c, so think like, let's say, x squared equals 9. Is there just one number that works in that equation, or are there two? There are two. What are they? So the common way to represent that compactly is to write this plus minus symbol. Have you guys seen that? So the square root property says if you have a squared equals c, then a equals plus or minus square root c. So one thing, if you were solving an equation like x squared equals 9, you might say, oh, I square root both sides and add in the plus minus, because both of those work. The most common thing is that students forget the minus one. Does that seem like a plausible? Yeah. Okay. And technically, so let's do example A 2 ways, because you can solve example A using the zero product property. You can factor and use the zero product property, and you can also do square roots. So let's factor first. How does 9x squared minus 16 factor?
3x plus 4, 3x minus 1.
Great, 3x plus 4. 3x minus 4. And then you solve 3x plus 4 equal to 0, 3x minus 4 equal to 0. So 3x equals negative 4. And what's the answer for the first one? Negative 4/3, great. How is the answer for the second one going to be different? It'll be positive 4/3, exactly. Okay. So that's the factoring way. That's one way. The other way is you could add 16 to the 0, and you could say, well, 9x squared equals 16. So this is, or you can solve it this way. At that step, what do you guys want to do to both sides? Would you prefer to divide by 9 or just square root right away? What do you think? Square root right away? Okay, so if you square root right away, what you have to do is this. You have to square root both the 9 and the x squared and the 16, and you have to add in the plus minus. So 3x equals plus minus 4. Does that make sense? And so then what's your answer going to be for x? X is plus or minus 4 over...
Wouldn't you have plus or minus 3x?
You don't, yeah, great technicality. You don't have to. It's kind of a, can I just say no? If you did, like if you had plus minus 3x, you'd have to solve 3x equals positive 4, 3x equals negative 4. You'd solve negative 3x equals positive 4, and you'd solve negative 3x equals negative 4. And a couple of them are redundant. Does that make sense? Like the answer you get from this bottom one is the same as that one. So you only need it on one side. So that's why. Good question, though. So can you think of one reason why method 1 might be better than method 2?
It's faster.
I think method 2 is probably a bit faster. Which method are you less likely to forget an answer in? I think the first one, don't you? So that's just my preference. But square roots are also fine. I don't care which one you use as long as you're accurate. So, all right, now how about part B? So part B is going to be a little bit funky. So let's, 2x squared plus 8 doesn't factor, does it? Other than a 2 comes out of it, right? So let's move the 8 over. We get 2x squared equals negative 8. And before we square root, can we divide by 2? Yeah, okay. So x squared equals negative 4. Great. Well, that's impossible, but we did learn about i's yesterday, right? So you can use those, yes. You say x is equal to plus or minus the square root of negative 4. So x equals plus or minus 2i. That's the reason to go over imaginary numbers, is that some solutions to quadratics are imaginary numbers. They're the only numbers that work. So that's the reason to go over it. So yes, you will have i's in some of your answers. And what that would mean in calculus, like if you get a question like this, is that the problem that you were trying to solve, there was no solution to it in the first place. So I can think of the one time I've had that come from my classes when students had to figure out where a function was like increasing, and they found that it like never was. There was something like that that happened. So i's are okay. You learned about them, you can now use them. And you can also use that square root property with stuff like this. So you could, theoretically speaking, expand that whole thing out, move the 16 over and factor. That would be hard, but okay. It's significantly easier, since you have something squared, to just square root this side and square root that side. And square rooting and squaring are opposite things, right? They cancel each other out. And you get 2x minus 5 equals plus or minus 4. So the only thing to really remember when you square root something is just don't forget the plus minus sign. That's the thing that gets forgotten the most often. And at this step, that is sort of two equations written as one. We have one equation that we could solve, that is 2x minus 5 equals positive 4. And the other equation we have is 2x minus 5 equals negative 4. And solving both of those will get you the answers that work in this equation. So the first one, you get 2x equals 9. So x is 9 halves or 4.5. Either one's totally fine. The next one, you add 5 and you get 2x equals 1. So x is a half or 0.5. Just a little bit about what method to use when the equation is written a specific way. Does that make sense? We're also going to use something similar to this to solve equations that you can't solve by factoring. Okay, is anybody freaked out by the fractions in part B, or are you tough enough you can take it? You can do it, right? You totally can. So square root both sides. That cancels the squared. So you got x plus a third equals, now can you square root 2? No, so let's just leave that as root 2. Can you square root 9?
Yes.
Yeah, so that you could say root 2 over 3. When you do that, make it totally obvious that the root is only over the 2. Does that make sense? Okay.
Do plus minus.
Oh, yes, I forgot that, just to test you guys. Yes, you'd also plus minus. Great. And then to get the x by itself, what would you do? Subtract 1/3. Yep, do the opposite. So usually it's written this way. It's usually written with the negative 1/3 first. But it doesn't technically matter which way it is. Yeah, so one of your answers is x equals -1 plus root 2. So negative 1/3 plus root 2 over, negative 1/3 plus root 2 over 3. The other one is -1 minus root 2 over 3, but you can't work out what either of those are because you can't work out what root 2 is, right? So it is totally okay if you leave your answer like this. It's just usually the case that the number with the plus minus in front of it is often written second. But technically it's not wrong if you do it the other way. Does that make sense? Does it also make sense? What is one more way you could write that answer because there is a common denominator? You could do -1 plus or minus root 2, the whole thing bob over 3. It doesn't matter to me which way you write it. Like, they're all good. They're all right. Okay. So as we discussed in an earlier section, I think it was section R3, there are some polynomials that you can't factor, right? They're prime. Does that make sense? Okay, and so, which means there are some quadratics that you can't solve by factoring because you can't factor polynomials. The question is, how do you deal with those? And the way you deal with them is you make them look like this. You make them into x plus something squared, so you can square root both sides. And when something isn't factorable, you're going to get an equation that either has imaginary answers or something that has irrational answers. These are still real numbers, but they're those numbers that never end, they never repeat, and their decimal, goes on forever. Right? Does that make sense? Okay. So to get to the method that we're going to use for that's called completing the square, and it has a pretty easy pattern for you to try to figure out what that pattern is. Oh, shoot. I was one step ahead of myself. Never mind. Next one. So still square roots, but imaginaries, right? So same thing, square root both sides. And i's are okay. So you get 5n plus 1 equals, plus or minus, don't forget it like I did,
3i.
3i. Great. So when your 1 moves from the left side of the equation to the right side, what does it become? -1. And I'm going to put it in front of the plus minus. So 5n equals -1 plus or minus 3i. And what's the very last thing you do? Put it all over 5. So n is equal to -1 plus minus 3i over 5. And I'm not going to do it because it's tedious, but actually this one's not as well. It's not awful, but I don't really want to. Technically speaking, if you plug this into your equation, it works. Let's see, let's talk about why that is. So if you plug this in, you got 5 times n, so what will happen to the 5? They'll cancel. Then you'll just have -1 plus or minus 3i plus that 1. What happens to the -1? Also cancels. And you get 3i, the whole thing squared. Isn't 3i squared the same thing as 9i squared? And doesn't that make -9? So like these answers, you could actually like check them by plugging them into your like expression to see if they're right. But often the checking is so tedious, your textbook was like, we leave this as an exercise to the reader and we're not going to check it for you. Which means they didn't want to type it all. So, but isn't that kind of cool that it actually works, it checks out. And that one wasn't very hard, was it? No. Okay, how about part B? So first thing you do is square root both sides, yep. So t minus 2 equals plus or minus the square root of -5. So t will equal, what does that 2 become when it moves to the right? +2. plus or minus, can you do anything with the negative 5 rooted? I root 5. And technically when you plug that in, it also works out. It's kind of crazy. A little bit, but. Okay. So let's figure out the patterns we can use this thing to solve any kind of quadratic equation. Like this method, factoring works sometimes, this completing the square method works all the time, as long as you're patient and can handle fractions. So, sorry my formatting stinks. So your first one is x plus 5 squared. So multiply that out, so do x plus 5 times x plus 5. What does that become when you multiply it out?
X plus 10x.
X squared plus 10x plus 25. B is x minus 1 times x minus 1, which is
X minus, or x squared minus 2x plus 1.
plus 1, right? Is that okay so far? C is x plus 4 times x plus 4, and that's plus, plus, great. All right, now there is a pattern here. What is the pattern that relates this number and this number? It's like, what would you, what do you do to this to make that?
Divide by 2.
Half of it's squared, you see that? So this last number is always half of this middle one squared, right? So half of 10 is 5, 5 squared is 25, right? Half of negative 2 is negative 1. Negative 1 squared makes 1, right? Half of 8 is 4, 4 squared is 16. See the pattern? Okay. So we're going to use that pattern to add a number in, like if we're missing that 16, and adding that 16 in is called completing the square. Because when you add it in, you make it into something squared. And we're going to use that to solve equations. So first, just tell me what number you would add to complete that square and to make the pattern we saw in the previous ones. So that first one would be 25. X squared plus 10x plus 25. And once you add that in, what does it factor into?
X plus 5.
X plus 5, or x plus 5 squared, right? All right, how about this next one? X squared plus 12x plus, great. And that would factor into x plus 6 squared. How about a kind of abstract one? Bx. You'd add x squared plus bx. You'd add b over 2 squared. Does that make sense? And then that would actually factor into x plus b over 2 squared. Because b over 2 times b over 2 makes b over 2 squared, right? B over 2 plus b over 2 makes b. Let's add in one more. Okay, just one more because I think you got some space for it. What if I gave you one that was like x squared plus 3x? Because it's a little bit harder when the middle number is odd. You add 3 over 2 squared, yep. And then how would that factor? X minus 3 over 2, exactly. So it even works with fractions. It's just half of that middle number squared. Okay, so, yeah.
When is the fraction at the end of it like that?
Mm-hmm.
It's a plus and a minus, not two plusing?
Oh, holy this should have been plus 2. No, I'm so sorry. Is that what you were going to ask as well, Holton?
Yeah.
Or Willow? Yeah. Yeah, I'm so sorry. They were both plus. Oh my goodness. Yeah, it's x plus 3 over 2 squared. I don't know why I said plus minus. Just I just shouldn't teach math at 8 in the morning, apparently. Yep, they're both plus. Okay, so let's use that to solve some stuff. I think that's what we're on next. Okay, so this method's called completing the square. All right, so if your polynomial factors, by all means, factor it is the best method. But with this one, are there any numbers that multiply to make -2 and add to 6? No. So in that case, you're going to use this completing the square technique, and the first thing you do is move that -2 with the 0. And leave yourself some spaces. So I've got x squared plus 6x equals +2. And now you want to make it look like those equations that were something squared equaled a number. So you have to add in a number to make it so one side is something squared. So the way you pick what to add, this is really clever. You say, oh, if I add in 9, that will factor into x plus 3 squared, right? And it's totally not fair to just add 9 to one side of the equation, right? That's not okay. So to be fair, and to keep the equation still equal, what do you have to add to the other side as well? Also 9. And that's the completing the square step. And it's called that way because you add a number in and you make it into an expression squared. You complete it. You give it that last thing that makes it square. And then once you're there, it's just like the ones we were doing, right? Does anybody also feel like that's a pretty clever trick, though? Like you pull a number out of thin air and add that number in. That's really a good trick. So x plus 3 will equal plus or minus the square root of 11, right? Is that okay? And so then what's your final answer?
-3 plus or minus 11.
Great. Okay. X squared plus 8x minus 3. So move the 3 over. What number do you add to complete your square? 16. Okay, and you're left with, on the left, how does that stuff factor now?
X plus 4 squared.
Mm-hmm. And as long as you add the right number, it's always going to be something squared, right? Okay, and that will equal 19, right? Great. And then you square root both sides, and you get x plus 4 equals plus or minus root 19. And what's your final answer? Great. Have you guys seen that method before? Did it make sense the first time? Nope, does it make more sense now? Yeah, pretty cool, isn't it? So now one thing that's a little bit tricky about this method is that the pattern that we're using to get this 16 depends upon the fact that this is 1x squared. Remember how factoring was harder when this was like 2x squared? Completing the square also, you have to have this being 1x squared before you start. If you don't do that, the pattern breaks down and fails. So before you start anything, you have to make sure that it's 1x squared, and you might have fractions that result if you make that happen. I think that's what the next one's like. Next one's 2x squared. So what you have to do, so it's 1x squared, is take the whole equation and divide it all by 2. So take whole equation, divide by 2. And then you get x squared minus 2x plus 3 over 2 equals 0. Does that make sense? Okay, now move the 3 over 2 to the right side, and we'll have x squared minus 2x equals negative 3 over 2. Now what do we add to both sides of that equation? Half of negative 2 is negative 1, right? Negative 1 squared will be 1. So add 1 there and add 1 there. And just be patient and just add stuff carefully. If you can be patient and just not freak out, you'll be fine. Not freaking out is very important. All right, now does x squared minus 2x plus 1 factor? Yeah, that factors into x minus 1. The whole thing squared, right? Now on the right side, does it make sense that 1 is actually 2 over 2? So negative 3 halves plus 2 over 2 is? Negative 1 half. Great.
Plus or minus.
Yep, so square root plus or minus. So x minus 1 equals plus or minus the square root of, the whole fraction is square rooted, right? The numerator is going to square root 2 I, right? The denominator is root 2. So x minus 1 equals plus or minus I over root 2. If you can get that from the first step, that's totally okay. Like if you can do this a little bit faster. I don't care as long as you still show some work, okay? Not as much as me necessarily. And then what's your final answer?
X equals 1 plus or minus I times the square root of 2 over 2.
I over root 2. And then if you, Daniel did one step, he also rationalized the denominator, which probably is a good thing to do. Like, I think that's okay, but some people feel very strongly about rationalized denominators, and Alex might feel that way too. So you multiply the second thing by root 2 over root 2, and you get 1 plus root 2I over 2. It's the equivalent. I'm okay with either one, all right? Doesn't matter to me, but just in case the Alex syntax wants you to always have rationalized denominators.
It's still plus or minus.
It is still plus or, man, yes.
Isn't I on the outside?
I is on the outside, but I tried to make my root sign end at the 2.
Okay.
I mean, like that is supposed to. If I wanted to go over the I would draw it all the way over the I.
Can you put the I in front?
Yes, you could. You also, to make it even clear, you could have said 1 plus or minus I root 2 over 2. It's even clearer that it's not underneath it. Then there's no confusion if your handwriting is messy. You know, which happens sometimes to all of us. Yep, and actually it is the case that the I's are often written in front of the root signs. It probably is. It's not better one way or the other, but, well, that's probably a little bit better. It's not wrong the other way. Okay, how about part B? Divide by 3. So we get x squared minus 4x plus, well, 13/3. Okay, weirdness. By the way, this would work to solve equations that factor as well. So, like, if you can't factor something and you can't figure it out, you could always solve it this way, just, you know, because. So take away the 13/3. So we get x squared minus 4x equals negative 13/3. What are we going to add to both sides?
Plus 4.
Plus 4.
Or 12 over 3.
Can I write just, yeah, it's good. Could I just write 12 over 3 on this side? Okay, great. Oops, did it wrong, my notes. Okay, great. So then it's x minus 2 squared equals negative 1/3? Okay, great. So x minus 2 is equal to plus or minus I over root 3. Is that okay? And so your final answer will be x equals positive 2 plus or minus I over root 3. Or if you rationalize your denominator, it's I root 3 over 3. So I'm okay with either one. But other teachers and Alex might demand other things, so just follow the directions. If they say rationalize denominators, rationalize denominators. If they don't, whatever. Okay, your book doesn't even go this hard, like I'm gonna go in example 10, but I'm not positive that Alec, because Alec does the randomizing thing, so they might do this not on purpose. It's a little bit more challenging when you have to deal with fractions. So this first one, I already put the 1 on the other side. What number do you add to the left side to complete the square? So half of 3.
9 over 4.
Mm-hmm. So, yep, half of thing squared, so 9 over 4, or you could leave it as 3 over 2, the whole thing squared, right? And the way you say mathematically the whole thing squared is use parentheses, right? Equals 1 plus 9 over 4 on that side, right? Because you square top and bottom, but yep. All right, awesome. Okay, so on the left, how does that factor?
X plus 3 over 2
X plus 3 over 2
squared.
squared equals
13 over 4.
13 over 4. Do you guys get how he got that? Okay. 4 over 4 plus 9 over 4. Okay. And you get x plus 3 over 2 equals plus or minus. What do you get when you square root 13/4? Does the top square root?
No.
Not nicely. Does the bottom square root?
Yes.
Yes, it does too. 2. And then what's your final answer? Mm-hmm. Mm-hmm. Great. So fractions are a little bit trickier, but not ridiculous, right? Okay, let's try another one. So for this one, can you do the complete the square right out of the bat? What do you have to do first? Divide by 2. Good job. So divide by 2. X squared minus 3x plus 7 over 2 equals 0. Okay, so now move the 7 halves to the right. X squared minus 3x equals negative 7 over 2. And what do you add in on both sides? 3 halves squared. The fact that that middle term is negative doesn't affect what you add, does it? No. So that's 3 halves squared, which is the same thing as 9/4. Great, good job. What that minus sign does affect is what you get when you factor. Does that make sense? It makes it x minus 3 halves squared. Equals, let's see.
Why is the 9/4 plus 9/4 on the other side? Shouldn't it be minus?
It's plus 9/4 on both sides.
We're not taking
No,
away
wait.
the other side.
Oh, wait, okay. Never mind, yeah.
Because you added it to the left, so you also added it to the
Yeah,
right.
I was thinking like minus.
You're thinking the minus sign in the middle somehow? Yeah, that affects what you get when you factor, but you could say it was technically negative 3 halves, the whole thing squared, which is the same thing as 9/4. Okay, the common denominator there, it's what, negative 14/4 plus 9/4, is that right? Which is negative 5/4? Okay, good. Okay, now square root both sides and we get x minus 3 halves equals plus or minus I root 5 over 2. Great. And so x equals 3 halves plus or minus I root 5 over 2. And if you had like infinite time and patience, you could really plug that in and it will work out. I mean, but that's like infinite time and patience. I want to do a couple of problems that aren't on there just because I think they're going to be good to review. So if you have some spare paper, let's write these down. Just say a couple of things before I do them. On your quiz tomorrow, I'm not going to put section 1.5 on there yet because I technically want to talk about it for one more day. So your quiz will only cover section 1.1, 1.2, 1.3, and 1.4. And by now, I know you've only recently had an assessment in Alex on chapter R. By now, we should have gone over most of the stuff in chapter 1 in class. We only have one more section, like half of 1.5 and 1.6 left. So by now you should be able to at least get through most of the chapter 1 stuff in Alex. So you really should have a marathon work weekend and get through it. So, and then if I decide to open up chapter R again and move its due date, I have to figure out what the consequences of that are. But it said that it would let you go back and work on it once you finish chapter 1. I want you to focus on finishing chapter 1. If you want to go back and work on chapter R, for now, get your butt through chapter 1 as fast as you can, and then you'll be able to go back, okay? So, and you'll be able to earn back some points so your grades get better and stuff. Okay, so
The quiz is gonna be on 1.1.
to 1.4. So just not today's lesson. So 1.1 was solving equations, 1.2 was solving inequalities, 1.3 was absolute values, equations, and inequalities, and 1.4 was complex numbers. It was yesterday. Okay, let's see. So what I was going to talk about was, what if you have something like this? 2x squared minus x, let's say, minus 1 equals 0. And we're going to solve this by completing the square. So what is the first thing you have to do? Divide by 2. So that gets you x squared minus a half x minus a half equals 0. So move the 1/2 over. And the things that most students have a problem with is halving a fraction. So what's half of a half? A fourth.
Would be plus 1/4 squared. Because you have to have it.
Mm-hmm. Yep. Okay, so then how does that factor? X minus 1/4, the whole thing, squared, equals, 1/2 plus 1/16, right? Okay, so 1/2 plus 1/16. 9/16, great. X minus 1/4. Oh my goodness, it's so much easier to teach this when people do it the second time. So 9/16. This one actually is going to work out nicely, isn't it? Yeah. So x minus 1/4 equals plus or minus, can you square root 9? Yep, can you square root 16? Mm-hmm, great. And your answer, your semifinal answer, is 1/4 plus or minus 3/4. So what's 1/4 plus 3/4? 1. What's 1/4 minus 3/4? -2/4 or -1/2. So my point wasn't that the method works when you have a polynomial that factors. It was more that if you half a fraction, it's like if you take 1/2 divided by 2, you get 1/4, right? What if you had 3 halves divided by 2? What does that make? 3/4. Does that make sense? So that's the thing. You can think okay, 1.5 divided by 2, that's 0.75, right? Or you can think, well, 3 halves divided by 2 is 3 halves times 1 half, right? That's also why it's 3/4. So when you half a fraction, the denominator gets multiplied by 2.
Wait. 3 halves is multiplied by 1/2?
3 halves divided by 2. Or 3 halves, divided in half means divided into 2 pieces, right? So when you take 3 halves divided by 2, it's the same thing as 3 halves times 1 half. Remember how division by a fraction, multiplication by the reciprocal, and the reciprocal of 2 is 1 half.
Oh, okay.
So my main point with that question is that when you have fractions, halving them is a little bit tricky. Does that also make sense? Maybe it's not tricky for you guys because you guys are good at this. You're better than the students I had who learned it for the first time. But, okay, so work on Alex this weekend. Have your quiz tomorrow. Happy studying. You can go 5 minutes early.